this is the topic related to the trends in distribution, SCADA, and control, continuation topic. So last class we discussed in trends in distribution, SCADA, and control. We are going to improve the communication between the control center and the distribution substation. So here in that point, the one of the component IEC. So in that point, one of the component IEC 61850. See that. So IEC, so this IEC 61850 will greatly improve the communication between the devices. So here, due to that, the vendors and utilities have agreed upon an international standard protocol. So why they are taken the agreement on international standard protocol? Because this IEC 6180 greatly reduces the configuration cost. Greatly reduces the configuration cost. And along with that, so it is a single standard device having the control of all devices, planning, engineering, and communication costs will also be greatly reduced. And next one is IEC 61850 supports to both client and next one is the server communication as well as peer-to-peer communication. So this IEC process bus will allow for communication to the next generation of smart sensor. And next one, due to that, here bringing these standards together will greatly reduce the cost of configuring and maintaining a master station through plug and play compatibility and database self-description. So due to these advances here, the advances in the graphical user interface and human machine interfaces will also greatly improve. So here, by the adopting of one device or one standard device IEC 6180, we are totally reducing the cost of maintenance in the distribution substation. Next, coming to point of the next topic is current trends in the current distribution management system. Current distribution management system. So current distribution management system. See that here, current distribution management system. Current distribution. See that here, that current distribution management system. So here in current distribution management system started with the simple extensions of the SCADA from the transmission system down to the distribution network. So like that here, we are dispatching the load in a large proportion by the system operation. Nowadays, so here we are using the manual and paper-based system with a little real-time circuit and collecting the customer data. Here, operators have to connect with the several systems and interfaces on the control desk. And next one, here, one of the important thing is here experienced operator is important. He is the key to the safe system operation. Why? Because with the increase in the regulatory influence, smart grids focus on the advanced technologies. Why? Here, the experienced operator having the capacity to control the latest advanced technology devices. That's why here, the technology increases, the government shows the renewed interest in increasing the investment in the distribution network to defer infrastructure build out and reduce the operating and maintenance costs. The distribution organizations have more interested. In increasing the asset utilization and reducing the operational cost. So that is those are the points of the current trends in the distribution system. And next, coming to point of the last point here, so it includes the load allocation, how much of load we are going to allocate it, and unbalanced load flow analysis have been developed by the distribution management system application. With the help of distribution management system applications, here load allocation and unbalanced load flow analysis switching order. Switching order. Here, switch order creation, simulation, approval, and execution, overload reduction switching, and capacitor and voltage control. So, with the help of these distribution management application, we are controlling the distribution network. We are controlling the distribution network. Coming to next. So here, two. So what are the mostly coming to point of in the distribution management system? Here, two important applications we are going to know. What are those two important applications? Those two important applications are two specific so two specific important applications are first one, they are reducing the customer here two specific examples of advanced application. What are those specific advanced applications? What are the advantages of those advanced applications? The first advantage of the main advantage of the advanced applications is reduce the customer outage duration. Reduce the customer outage duration. What are those advanced applications? The first one is fault location application. Fault location application. And the second one is the first one is fault location application, and the second one is the restoration switching analysis. Restoration switching analysis. Here, some of the distribution management applications we are commonly used today. Some of the applications of distribution management system. In that, first we are going to discuss about the FDIR. FDIR. What is FDIR? Fault detection, isolation, and service restoration. Fault detection, isolation, and service restoration. It is designed to improve the system reliability. Why we are using the FDIR? FDIR is designed to improve the system reliability. It detects the fault on feeder section. It detects the fault on feeder section based on the remote measurements. Based on the remote measurements from the feeder terminal unit. After finding the fault, here quickly isolates the faulted feeder section. A feeder is a fault know that feeder will be isolated. And next one, it restores the service. Again, it restores the service to the unfaulted feeder section. Unfaulted feeder section. It can also reduce the service restoration time. Service restoration time from several hours to a few minutes. By this, considerably improving the distribution system reliability and service quality. Distribution system reliability and service quality. Here, this fault location estimates. Here, this fault location application estimates the location of an electric fault on a system. What is the main objective of this FDIR or fault location application is to estimate the location of the fault, where the fault is located, at what distance here the fault is located. Here there is a difference between the protective device and fault location application. Protective device is it has the ability only to protect the device whenever the fault is occurred. But the application, the work of the fault location application is to identify the fault location where the fault is occurred, and that fault is isolated from the faulted feeder and restored to the unfaulted feeder. Restored to the unfaulted feeder. So this is the different than identifying the protecting device. And next one, due to the a customer here. The location of the electric fault is, what is the location of electrical fault? Electrical fault is where the short circuit occur due to the result of vegetation, here wildlife animals, lightning, or something else. So because of this here, faults are occurring the faults are occurring on the feeder. Faults are occurring on the feeder. And next coming to point. See here. So with the fault location of application, it is very easy to the staff. Staff is nothing but the crew or staff in the electrical department. So they are very easily identified the location of the fault on the long run conductors. Long run of the conductor is very length of the very long length of the conductor. And next one, in case if there is no fault location, there is no fault location of the, it is more difficult to the crews or troubleshooters to identify the where the fault is occurred by the terrain, the rain condition, snow condition, the darkened areas or mountain areas or hilly areas. It is difficult to the electrical department people to identify where the fault location, where the fault. So due to the fault location application, the more time required to locate the fault, the more time consumers are without power. More time. Here, without the fault location app, the more time required to locate the fault, the more time consumers are without power. So due to that here, with the help of fault location application, here we are designing the logarithmic based algorithms. Here, as operated electric network model, including the circuit's connectivity, location of open switches, and length and impedance of the conductor segments, we estimate the fault. Here, distribution management system, with the help of fault location application, we are preparing the algorithm. We are preparing the algorithm. In that algorithm, we are connecting the all circuit components of the network and location of the switches and the impedance of the transmission lines and conductors. Okay. So due to that, the fault current information such as magnitude, how we identify the fault is occur, the magnitude of the current shows or increases, here the fault will be occur. This predicted with the type of the fault, either face to face or face to line. Faulted phases is obtained by the distribution management from IEDs, such as relays, recloser controllers, or RTUs. So these are the elements used in the distribution management system, IEDs, intelligent electronic devices. So here, with the help of these fault locations, we are reducing the time required to identify the location of the fault to the few people, and along with that, we are reducing the time of outage to the consumers. And next one, in case of this fault location application, identify the fault where the that location is sent to the operator. So through the graphical interface, geographic information system, or next one Google Map. By that here, they are getting the information and they went to the exact location to troubleshoot the problem. That is about the FDIR. FDIR. What is FDIR? FDIR is the fault detection, isolation, and restoration. One more application is the restoration switching analysis. One more application is the restoration switching analysis. This restoration switching analysis is the one of the advanced application. Is the one of the advanced application used in the distribution management system. It improves the reliability performance indices. It improves the reliability performance indices and evaluation of all possible switching actions to isolate the permanent fault. Here, they are going this application RSA evaluate the closing or opening of the switching actions to isolate the fault. And next one, this can be suggested switching action to the operator. Suggest the switching actions to the operator. So then the customer restore. Whenever the fault is occurred, the switches are open with the help of the restoration switching. When the switches are open, after restoration of the fault, again the switches are closed with the help of the restoration switching analysis. So due to that, here the occurrence of the permanent fault and occurrence of the permanent fault will be reduced, and the application evaluates the switching action in which line the switching is working on. And next one, they are executing the unbalanced load determine the overload lines and low voltage violation. Overload line and low voltage violation. And next one, it is particularly valuable. This RAC application is particularly valuable for heavy load condition, whether the potential switches are high. Potential switching action is high. This application can execute with the operator. This application can execute with the operator in the loop or in a closed loop manner. So here, whenever the fault is occurred in a closed, whenever the fault is occurred in a distribution system, so this application collects the information, and next one it acts the perform the closing or opening of the switches. And next one, how they are opening and closing actions are done with the help of the communication network. So this communication network having a SCADA, radio, phasing, or potentially AMI infrastructure. AMI infrastructure. So such a automated isolation and restoration process here, smart grid is a self-healing characteristic. Smart grid has a self-healing characteristic. What is mean by self-healing characteristic? So itself clears the fault, identify the fault, and that fault is cleared itself. That is we call as self-healing property. Self-healing property. This characteristic is the main for the switch smart electric grid. Here, one more application of the distribution management system. So this is the integrated volt and volt ampere control. VAR, volt ampere reactive control. What is the full form of VAR? Volt ampere reactive control. It has the three basic objectives. What are the three basic objectives? The first objective is here reducing the feeder network losses. How we are reducing the feeder network losses? By energizing or de-energizing the feeder capacitor banks. That is the first objective. And second objective is we are maintaining the optimum voltage profile along the feeder during normal operating condition. Under normal operating condition, we are maintaining the normal voltage profile, optimum voltage profile. And the second objective. And third objective is we are reducing the peak load through feeder voltage reduction by controlling the transformer tap position. So by controlling the transformer tap positions, we are reducing the peak load on the feeder. Reducing the peak load on the feeder. And next, with the help of voltage regulators, we are controlling the feeder voltage on the feeder. So along with that, we are designing the advanced algorithms are employed to optimally automatic opening or closing of the capacitor bank. That is the control of the capacitor banks, voltage regulators, and transformer tap position. It is the one of the DMS application. And the next application is the topology processor. The topology processor. It is a background of the DMS. Topology processor is a background of the DMS. Offline processor is an offline processor that accurately determines the distribution network topology. Topology is nothing but connection. Topology is nothing but a connection or interconnection. We are connecting the circuit. So, and connectivity for display the polarization and to provide accurate network data for other DMS application. So, this topology process provides the intelligent alarm processing. Why? To suppress the unnecessary alarms. Suppress the unnecessary alarms due to topology. Due to topology changes. And next here remaining next applications of distribution management system. Distribution power flow. Distribution power flow. We are distributing, we are transferring the power to the consumers to the distribution lines. We are distributing the power flow. So here the distribution power flow, it solves the three-phase unbalanced load flow. It gives the solution to the three-phase unbalanced load flow for both. Best connection is nothing but the loop connection, or radial operation is nothing but the parallel operation of the distribution network. It is the one of the core module in a distribution management system. So with the help of this distribution power flow, the results are utilized the results are used by many distribution management system applications. What are some of the here, such as FDIR and IVVC for analysis? FDIR and IVVC for the analysis. Next one, load modeling and load estimation. Load modeling and load estimation. modeling and load estimation. Load modeling and load estimation is a very important base model in DMS. So dynamic load modeling and load estimation uses all the available information from the distribution network. It uses all the available information from the distribution network, including the transformer capacities, and customer monthly billings. So here in our electricity bill, here our load capacity is mentioned, how much amount of load in our house, like that. Here combined with the real-time measurements, how by combining the real-time measurements along the feeders to accurately estimate the distribution network loading for both individual loads and aggregated bulk loads. The effectiveness of the entire distribution management system relies on the data accuracy provided by the load modeling and load estimation. If the load models and load values are not accurate, all the solution results from the distribution management will be useless. So these are the some topics we discuss, students.